So, my dear friends, Nirma Oza presenting to you tutorial number 27. And we are in the series of line differential protection. So, it is line differential protection number 2. Number 1, we have seen a simple conceptual wire pilot type differential protection. Here we will see the carrier equipment to transmit the signal. And finally, our opinion, our goal is to see to it that both the breakers at both the ends of the line trip simultaneously and reclose simultaneously so that our system does not become unstable. So how that is done? By different carrier schemes that we would like to see in this tutorial as well as next tutorial, which will end line differential. Going further, in carrier current protection, what do we do? That we were laying wire pilots, we were laying separate pilots. But already the transmission line is there, which is running from one point to the other. Why not to use the same transmission line as pilot? That laying separate pilot, it is better to use the same transmission line as a pilot. So what we do is normal power frequency current at very heavy megawatt, 200 megawatt or 300 megawatt is flowing. But our carrier signal at very low voltage, at very low wattage, I should say, at very low wattage, but at very high frequency in the range of 300, in the range of 30 to 200 kilohertz, will flow to run the information, run many information. And transmitter will transmit the information at high frequency, receiver at the other end will receive, and it will do the function. That is a carrier channel. Another is microwave pilot also, but it is working at ultra high frequency. It is working at radio system operating operating above radio system, 900 megahertz. So if you use a microwave pilot, then you need not use the transmission wires also. You can throw the waves to the satellite and satellite will receive and it will throw the waves to the other end. Microwave pilot is not much used. We are using usually carrier pilot. So we will discuss the carrier pilot schemes. We will discuss carrier current protection in detail. See, carrier current protection or line differential protection is a unit system. Unit system means on both the sides there are CTs and between the two CTs is a zone of protection. Beyond two CTs is if the fault occurs, the system should not operate. Right. And using this carrier channel, circuit breaker at both ends of a transmission line will trip simultaneously and reclose simultaneously. But the problem is this carrier current protection necessitates very costly carrier equipment. We will not be able to discuss all carrier equipment because that is not our subject. That is the subject of electronics or electronics and communication people. So electrical people are not to worry about the repairs and maintenance of those equipment, but we should know some of those equipment which are of our interest. So we will see the equipment which are of our interest. So the equipment is like this. There is a line AB, which is obviously fed from both ends, because you see, when we are using carrier current or distance, we are taking it for granted that we are working in an interconnected system. So it is fed from both ends. But usually the power would be flowing either from A to B or B to A. But when fault occurs, power will be fed from both ends. So here that fault condition is shown. At end A there is relay RA, and at end B there is relay RB. When there is a fault between AB, between two cities, RA will give signal to breaker A. Breaker A will trip locally. But at the same time, at the same instant, breaker B should trip. How does it trip? When relay array operates, it triggers a transmitter also. And that transmitter gives a signal to coupling capacitor. Now, the function of coupling capacitor 1 upon 2 pi Fc. Xc is equal to 1 upon 2 pi Fc. So, it allows only high frequency signals because Xc is very low. So, it allows only high frequency signals to pass through. In transmission line, power frequency signal is passing 500 megawatt, 200 megawatt, 300 megawatt. That does not come down. That does not come down to coupling capacitor, because coupling capacitor will rather show very high impedance, will oppose that, will not allow the power frequency signal to come down. Only carrier frequency signal, high frequency signal will go to the transmission line. So in transmission line, both the signal will get mixed, power frequency and carrier frequency. So when it goes to the other end, carrier frequency signal comes down to CC and B. Carrier frequency signal comes down to CC, and it will go to receiver. The receiver relay will ignite RB and it will trip breaker B. Thus, breaker A and B trip simultaneously. And because they trip simultaneously, they are close simultaneously. So our purpose is served. But these equipment are very costly. I am showing only transmitter and receiver, chalk coil, this and that, wave trap. But there are many more equipment. There is such a carrier room in which everything is there. So the equipments are quite costly. So another equipment which you can see is line trap. Line trap is a parallel resonant circuit of L and C. So what does it do? It allows power frequency signal to pass through. It offers hardly zero impedance to power frequency signal. But carrier frequency signal, it will not allow to pass through. Otherwise, what will happen? Carrier signal sent from end B will pass through that and it will cross A and it will interfere beyond A. That is not required. Carrier has to work between A and B only. So carrier signal is not allowed to pass. Exactly the reverse work than CC. CC allows carrier signal and not power signal. Line trap allows power signal and not carrier signal. Right. Over and above, you can see chalk coil is provided, because you see, when I say power signal is not passing through CC, but CC 1 upon 2 pi FC, XC, F is very 50 hertz, so F is very small, but that small current will pass through. That small current also can go to carrier equipment and can damage that. so that it does not damage, CCN check choke coil makes a resonant circuit, series resonant circuit. And whatever small power signal that if at all it comes, it is grounded. It is grounded. So that is the function of choke coil. Spark gaps are kept to protect the choke coil against lightning strokes. So this is the figure of carrier equipment. So I have shown to you how A and B will simultaneously trip, right? Similarly from B to A, if there is a fault near B, that means fault is near B, then B will trip locally and it will send carrier signal to A. So that can be done. So some write-up with reference to that is written. The cost is very high. The cost of these equipment is very high. So how can you justify a cost? To justify a cost just for protection is not good. But fortunately, this carrier current equipment do many functions. One obviously protection. And it gives a very good unit protection scheme. Another important function is communication. You can talk with the another substation, another power station using carrier system. You do not need BSNL people. You are talking to each other in power station free of cost. Substations, power stations, you can talk free of cost. Right? Supervisory control. A breaker at any remote location can be controlled using the carrier network. You see, if you want to shed some load and you do not have time, system is going out of step very fast and you have no time to call the another person to shed the load, then you don't call him. You push the button and the breaker at somewhere. You are pushing the button at Ahmedabad and breaker at Surat trips. You push the button at Delhi and breaker at Lucknow trips. That remote control is possible using this carrier current protection. The another advantage is telemetering. Right? Telemetering means what? You see, it is nowadays it is load dispatch centers are there. In Gujarat, there are 3 area load dispatch centers and 1 state load dispatch center at Godri. What is the function of load dispatch center? They have to match input and output. They have to match income and expenditure. Whatever power is generated, that has to be distributed. If generation is less and load is more, then system will be out of step. If load is less and generator is more, then also system will be out of step. So they have to match that. If load is more, they have to shed the load. And if generation is more, they have to ask the generator people to reduce the generation. So that is the business of load dispatch center. It's a very important function. It's a very important station in the power system network. But for that, it is very necessary that they should get information from all generating stations, generating plants, and all important substations. If I mistake not, some 13 substations are identified in Gujarat and all power stations in Gujarat. Say, load dispatch center at Gotri, the chief engineer gets information from all generating stations. If one generating station at Vanakbori trips, he immediately knows, immediately at that very moment he knows that it has tripped. Because it has tripped, the load has reduced. I mean, the generation has reduced. So load has to be accordingly reduced. That is telemetering. The megawatt is lost at Vanakbori and person at Gotri knows. So what is the voltage at different substation? What is the kVAR, MVAR at different substations? What is the power factor at different substation? What is current incoming? What is current outgoing? All informations through carrier is sent to load dispatch center. Very important function, right? To keep the income and expenditure, to keep input and output equal. And obviously local metering, because you have got coupling capacitor. So in series with coupling capacitor, if you connect a low voltage capacitor, you can get a low voltage 110 volts, and you do not require separate PT. So a cost of PT is saved. So because of so many exam advantages, because of so many functions that the uh, carrier current equipment perform, they are justified. That one should know. Carrier current protection is used in two ways. Either the carrier signal will trip the relay, then it is tripping carrier, or it will block the operation of the relay, then it is blocking scheme. Right. So there are two schemes, blocking scheme and tripping scheme. So when carrier is received, the tripping will be blocked, that is blocking scheme. And if carrier is received, tripping is allowed, that is tripping scheme. So we will study first the phase comparison or directional comparison scheme first. So this is the description of coupling capacitor and wave trap, etc., which I gave to you. So how does RA and RB trigger the transmitter and operate? That also I talked to you. So let us talk about phase comparison carrier current protection scheme. Let us assume that the scheme operates on blocking principle. So you have to refer to figure 9.4. So I'll talk in terms of figures only. This description you can read. I will talk in terms of figures. Say between line AB there is a fault. Between line AB there is a fault. So let us see. Between line AB there is a fault. Let us see. Between line AB there is a fault. Between line AB there is a fault. Sorry, there is no fault. Let us take first the case of no fault or an external fault. Then current flows from A to B. So for CT at A, current is flowing away from the bus, and at B it is flowing towards the bus. So if you plot the curves, what do? They, if you see the wave shape, it is like this. At A, but at B it is like C. At B it is like C, because it is 180-degree phase shifted, because current is flowing towards the bus. Now that bus, that current that is flowing is rectified and modulated. It is rectified and modulated. So wave shape at A which you see is rectified and modulated as shown at B. So negative cycle is clipped. Only positive cycle will appear. At B, another substation also it will be rectified and modulated. So if you see at end A, half cycle, the signal is not available. But from B, it is transmitted to A via carrier signal. You see, carrier signal is there. We have seen. Carrier signal is there. We have seen. Carrier signal is there. So whatever output is there at B, is transmitted to A. So when it is transmitted to A, another half cycle which is empty is now full. Similarly, at B, from A to B it is transmitted. So at both the ends, carrier modulated signal is available. And because it is available and it is a blocking scheme, if carrier is not available, then only tripping will occur. Here tripping will not occur because fault is not there or external fault is there. Therefore, tripping will not occur. Should there be an internal fault, my dear friends? Should there be an internal fault? Should there be an internal fault? Then fault will be fed from B also. So both will be away from the bus. Both will be away from the bus. So both wave shapes will be like this. Both will be, wave shapes will be as at A, not as at C. So at N, A and B, modulated and rectified wave shape is as shown at B. And when it is transmitted like this also. Is only. So for half the cycle, carrier signal is not available. So there is, so because carrier signal is not there, tripping is allowed. It is blocking scheme. Blocking, there is no carrier signal, therefore breakers at A and B will trip simultaneously and breakers at A and B will reclose simultaneously. Our purpose is served. Our purpose is served. But the biggest disadvantage of this carrier scheme is there is no backup. If carrier fails, carrier equipment can also fail. Breaker can also fail. Relay can also fail. If anything fails, then there is no backup. There is no another relay to backup. Yes, that is true. That people go for, because this carrier is transmitted over one wire out of three wires. Because there are RYB three wires. Carrier is transmitted over three wires. People think of a scheme that duplicate scheme. Another carrier is transmitted over second wire. Then if on one wire it fails, second wire it will be working. But then it is too costly. Then it is too costly. So that is the problem, my dear friends. So with that, I end this carrier. Carrier is a little difficult to understand. I could not go below this. So I will read a sentence. Creativity is the greatest rebellion in existence. Osho says that you have to be creative. Be creative. That is his saying. With this sentence, uh, I cannot remain without remembering Adapt Me, because Adapt Me gives us a chance to meet on this platform. So please use this platform. And it is quite possible that you are doing something else. You are not in engineering field now. You are in managerial field. You are in altogether a different field. You have lost electrical. You have completely, you are out of electrical. Protection is too specialized a subject. So even if you are in electrical, you may not be in protection. But at least you might be knowing many people who are in protection, because you might have friends. So you can do one favor for me. that you can share this video to as many people as you can. Particularly my dear student friends, some 1600 friends whom I taught. For 3 semesters, I was teaching them for 12 hours if they know. I have reduced my blood. I have given my blood to them. I have given myself to them to teach them. So they owe me that much, that they should share to 100 people, 1,000 people, as many as they can. 15 people, 10 people, as many as they can. So that this video is read by many. Because you see, in social media, views and view hours, how many hours they have viewed the video, that is important. And that carries importance. So, my dear friends, I would all request you, all is that please share this video of Adapt Me. Adapt Me is giving something to you and at no cost. So friends, with those words, thank you and good day.